All right. So, last day we were looking at these guys here, all our HOH, pH, pOH, KW, pKw, page 73. And I don't think we got very far through this. If we have the log of 10 to the 7, what is the answer to that? 7.
Okay.
Okay. Now, quick question. How many sig figs here? 0 sig figs. Did we do this yesterday? Yes. Okay. So how many sig figs here? 0 sig figs. Excellent. Okay. What if we have the log of 1 times 10 to the 4? What is the answer? 4.0. Did we do this one yesterday? Did we? Okay. I don't know what happened. I'm not on my computer, so it's not like showing what we did. It's showing what the other block did. I don't know. It's confusing me, but it's all right. It probably just didn't sync, but whatever. It doesn't matter. So we have 1 sig fig. And we have 1 sig fig. All right. And did we take the log of 5 times 10 to the negative 5? Did we do that? Okay, everybody check that into your calculator. 5 times 10 to the negative 5 and take the log. Where's my calculator? Ah, there it is. Thank you. So I get negative 4.301. What would our correct answer be there? Negative 4.3. And that gives us how many sig figs here? 1 sig fig. Okay. Because this negative 4 actually relates to this negative 5. It's just because this number is bigger than 1, we end up with the number being 1 greater or less or whatever it is. Okay, don't worry about it. Don't think about it too hard. Just keep moving. Okay. All right. pH is, of course, the negative log of H, or what's the other way we can write it? Negative log of H 3O plus. Okay, both of those are correct. So if we are doing this next question, let's find the pH if we have a hydronium concentration of 3 times 10 to the negative 3. And you should show your work for this. Every time you do one of these questions, you should show your work. So I got 2.5229. Did you guys get that number? How many sig figs should we have? We should have 2 sig figs. So what should this round to? 2.52, right? Because only digits after the decimal are significant in p values. pKa, pH, pOW. There's pH, there's pOH. What's the other P thing that we have? pKw, yes. What's Kw again? Kw is the it is the constant, equilibrium constant for the auto-ionization of water. I believe that's a term we did not get to yesterday. Do you guys know what the prefix auto means? By itself. So an automobile is mobile on its own. It doesn't need a horse to pull it. Yes? So if we have the ionization of water by itself, that means that water is ionizing water. Yes? So if we were to write the auto-ionization of water, that would be water plus water what do we get as our products there? H3O plus OH minus. Okay, and Kw is the equilibrium constant for this reaction. So Kw then is hydronium, H3O plus, times hydroxide. Is good? Okay. What's the value for that? Yeah, 1 times 10 to the negative 14. Okay. Alrighty, have we missed anything in here? I don't think so. I think we're good. We can carry on to our next page. I would like you guys to try the following. Show your work. The reason I'm really excited about you showing the work is that number 1, the AP exam likes you to show the work. Number 2, I like you to show the work. And number 3, I know that university professors like you to show the work because there was a time several years ago when my former department head and I took our students up to a lab at SFU, and one of the professors was up there and they're like, "Oh, you guys are from Burnaby Mountain. Oh, your kids know how to show their work really well," because we really made a focus on that. So they liked it. So it's not just me, it's not just AP. All people who are marking your things like it when you show your work. So please do it. Yeah. You don't have to show the formula every time for this one because it's such a basic formula. You just need to write the negative log and then stick the number in. I think in the past, I used to make people always write negative log of concentration of hydrogen, but I feel like that's not necessary. Maybe I'm just getting old, I don't know. Yes. How do the sig figs work? Okay, so here we have two sig figs, yes? And in the p-value, only numbers after the decimal are significant. And that's because this 11 here relates to this power of 10 here. Now, there's a reason that I made the coefficient part of the number the same in both those cases, because it shows you that if your coefficient in that scientific notation is the same, you will get the same decimal, right? 5.4 times 10 to the anything is going to give you something 0.27. Yeah? So this is the part of the number that comes from here. And this part of the number comes from here. Yeah? So that's where our two sig figs come from and our two sig figs. Yeah? How many sig figs should we have in C? We should have 3 sig figs. So how many do I have here? Right now I only have 1, so I would have to put a 7 and a 6, and that would give me 3 sig figs. Okay? And then what's our last one? 1.9 times 10 to the negative 17 equal log. Now, I put these ones specifically in here so that you are, reminded that pH can be negative, right? And pH can go above 14.
Why is that again?
Why is it? Because if you have a really high concentration, like if you have a concentration that isn't times 10 to the negative something, like if you have 1 molar, that's going to be a pH of 0. If you have 2 molar, that's going to be a pH of negative 0.3. If concentration of H plus is 1 molar, that is 1 times 10 to the 0 molar, yes? So that's going to, so the pH is going to be 0, yes? Now, if I have, let's say I have 10 molar, concentration of H plus is 10 molar, that's going to be 1.0 times 10 to the 1 molar. My pH is the negative of the log of 10 to the 1, so that's going to be negative 1. Yes? So if you have a positive exponent here, that becomes a negative pH. Yeah? Totally fine. It just doesn't crop up a lot.
Basically, it just goes over the scale.
Yeah, it just goes over the typical scale that we're used to seeing.
So you can-
The scale doesn't end at 0 and 14 is what we're saying. Yeah? Okay. It doesn't end where we think it ends. It just doesn't usually go in that direction because usually our hydrogen ion concentrations are smaller than that. But it can, yeah. Yeah, theoretically, yeah. Now, autoionization of water. The reality, we just wrote that down, is H2O plus H2O. And we get H3O plus OH minus aqueous and aqueous. Now, shorthand, I bet you guys don't know what shorthand is. Am I correct?
That's short.
A hand that's short. Here, we're going to go look up what shorthand is so you can see it. Because I don't know any other way to say it. Okay, there we go.
What?
So, shorthand is a way of writing quickly. Okay?
Wow.
Back in the olden days, let's say you were the CEO of a company and you want, or even just, someone who's working and you needed to write a letter to somebody. Okay? Mostly these people did not type their own letters. Okay? There were no computers, right? And typing is a skill. And if you cannot do it quickly, then, it takes forever to get it done and you would have mistakes all over the place and it doesn't look professional to send out this thing with mistakes. So if you were the person who was doing this, you usually had a secretary and you would dictate your letter to the secretary. So you just talk, okay? And the secretary would write down what you said. Now, in order for that secretary to keep up, they needed to be able to write very quickly. So rather than having like all the words, they would have symbols that just shortened everything. It made writing very, very fast. So they would take it in shorthand and then they would take their shorthand notes and they would type it up. So if you were a secretary, you would train in shorthand and you would train in typing so that you had a very high accuracy in word count per minute. Okay, so that was how it worked in the olden days. So what is shorthand? Shorthand is a way of writing things more compactly. Okay, text speak is a version of shorthand. Okay, because, you're like IMO, WTF, right? Like all of those things are shorthand for what they really are. Yes? I don't know. I never took shorthand. Oh, there's two different versions. There's the Pittman style and the Gregg style. There we go.
For Pittman, K and G are the exact same.
Well, I think it's because they make the same sound. I think it's based on phonemes. I don't know. Don't look at me. It was gone before my time. People were not doing shorthand anymore. Where did my OneNote go? There we go. Okay. So the shorthand method for doing this is a shortened version. I guess I could call it the shortened version, but shorthand. You should know the word shorthand. It will come up with old people like me. H plus, aqueous, plus OH minus, aqueous. And besides which, now you know a random trivia fact that lots of people your age don't know. So it is okay to write the autoionization of water either way. Okay, which one is more correct? This one is more correct. Yes, because in reality, the water is acting as a Bronsted-Lowry acid and as a Bronsted-Lowry base. Therefore, water is, what's the word? Amphiprotic, yes. Okay, so let's write our KEQ expression for the ionization of water two different ways. We already wrote it one way, but let's write two different KWs. Because you can use the shorthand one, yes. I would probably tend to, let's see, what did they give you in the AP data booklet? Because although you have to memorize these things for regular chem, AP gives you all of these. And they use H3O plus. So I would use H3O plus when I'm doing AP Chem because that's what they give you, right? We've got pH, pOH, we've got KW, we have pKw. There we go. Okay? So, using H and KW to find OH. So we know that KW is equal to H3O plus times OH minus. It is also equal to H plus times OH minus. So how would we calculate concentration of hydroxide then if we are given the hydronium? KW divided by concentration of hydronium. Okay, so you would have 1.0 times 10 to the negative 14 over 3.0 times 10 to the negative 3. Again, because it's a K calculation, you don't need units. And we get 3.3 times 10 to the minus 12. And because it is hydroxide concentration, we need to say molar. Is good? Okay. This just goes over pOH, but it's pretty much the same. Okay, do we need to go through an example like that? Do we need to? Negative log of H. Negative log of OH. You don't have to write this down if you don't want to. OH. Ooh, I'm not going to have you do this because this seems too simple. Yes? Okay. Find the concentration of OH and pOH of the following solutions. So it's a good thing this is written out because we've only got like 4 minutes left, I think. No, we have 9 minutes left. Okay, we're good. However, it's still good. If I was to give you hydrogen, that does not mean that there is no pOH. You can go from hydrogen, you can go to hydroxide, yes? And then from hydroxide, you can go to pOH, yes? What do we use to get from hydrogen to hydroxide? KW over the concentration of H plus, yep. Okay, and what do we use to go from hydroxide to pOH? Negative log, okay? So what you would do is you would say, okay, I've got my hydrogen ion here. I know what that is, so I'm going to plug it in here, and I know my KW, and I get that number over there. This is my concentration of OH minus. Then if I want my pOH, I just take my OH minus and I stick it in there. And of course, we've been working with 2 sig figs. So the negative log of hydroxide, negative log of blah, 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 equals 2.73. Do we need to do the next example or are we good? We're okay. All right. Excellent. All right. You can do these on your own. Okay. If you need to. We're going to skip ahead and look at pH, pOH, and pKw. So we already know this because we've covered it already. pH is negative log of H, pOH negative log of OH, and pKw negative log of KW. This just shows us that pKw, what is pKw equal to? pH plus pOH. So that's another one you can use. You can use that to go back and forth between pH and pOH. Blah, blah, blah. Here's the derivation. We did that the other day. We're not going to do that. Here is a handy little chart that is given in Hebden. So you can go back and forth between H3O plus and OH minus using KW. Is that top part okay?
Yes.
Yes? Okay. We can go back and forth between pH and pOH using pH plus pOH equals pKw, which is 14, and this is 1.0 times 10 to the negative 14. We can go from hydronium to pH using negative log of hydrogen. How do we go backwards? Yeah, concentration of H3O plus is 10 to the negative pH. I've not left myself much room in there. Okay, so that's to go upward. And we can also go downward. We would use pOH is equal to negative log of OH. But if we wanted to go from pOH to H, what would we do? Yeah, OH minus is 10 to the negative pOH. And that would take us up. So do you see how I could give you any one of these things and you could get to the other? So if I gave you H3O plus, you could do the conversion in 1, 2, 3 steps, or you could just do it in 1 step if you wanted to get to OH minus. Yes? If you want to take the long way around, nobody is going to stop you, but it is inefficient. So it is good to be familiar with all the different ways that you could go. If you are given a pOH and you want to find H3O plus, you could take pOH and go to hydroxide, and then you could go to hydronium. Yeah? Or you could take your pOH, find your pH, and then go to hydronium. Does it matter?
No.
No. So once you feel comfortable with this little chart, you can stop referring to it. Yes? If you like using it at the beginning, that's fine. Okay? We're just going to quickly on page 78 do our sig figs for going backwards. Okay, so example 4 on page, did I say 78?
Yeah.
Yeah, okay. There we go. Okay, so if our pH is 4.0, how many sig figs? How many?
1.
1 sig fig. So when you then go to calculate the hydrogen ion concentration, you will take 10 to the negative pH, which is going to be 10 to the negative 4.0, which is going to be 1 sig fig, times 10 to the negative 4. People sometimes are okay going in one direction. They're like, oh, okay, I can find pH and know that I have to have that many decimals, right? But sometimes when you go backwards, you have to remind yourself, if I have this many decimals, that's how many sig figs I have, okay? So it needs to have 1 sig fig. How about this next one? If pH is 1.00, how many sig figs? 2 sig figs. Okay, so that's 10 to the negative pH. Oh, and it's a negative 1.0, so it's a negative of negative 1.0 because we're taking 10 to the negative pH. So the negative of negative 1.00. And that's 10. We get the answer 10. How would we have to write that with correct sig figs? You could either write 10 molar, or you could write 1.0 times 10 to the 1 molar. We're going to have a quiz on pH and pOH next Wednesday. Okay? Just 4.2. Sorry, 4.2. 4.2.
Maybe we didn't.
So go home and do all of this, and then we'll only have at temperatures other than 25 left to do on Monday. No worries.